have the power. Hey, with the MLS working group, starting at 1350, so that's right about now. So let's get going. Get closer to the mic. Okay, MLS at IETF 104. Thanks, everybody. Oh, okay. This is the note well. Let's just start to look familiar. Basically, whatever you say and do will be held against you later. If you participate, you're going to be recorded and videotaped like you are here. If you have any IPR, you need to declare it, obviously. We've got some processes and procedures that you can read about from the list there. That's about it. Requests. We have a JabberScribe. Thank you, DKG. Who would? Okay, so we need a JabberScribe and we need a minute taker. So minute taker, oh, you do minute taker. All right, great. And if you have to bail, then we can swap. That's awesome. There's some blue sheets going around. I appreciate that. If you do the minutes in the Etherpad, then other people can link into it as well. Do you know where that is? All right, cool. Please state your name at the mic, and as well, keep it professional at the mic. Here's our agenda. 2 days. They were generous. We only actually asked for 3 hours, and they gave us 3.5 hours. So today we're going to do some reviews, some interop stuff, do the interim recap that we're going to do, and then we're going to go over our architecture document, and then we're going to start kind of plowing through the protocol issues that we have open. Then we're going to talk about a new draft that Ahmad started talking about at the last interim for federations, and then Sophia has some stuff on deniability, and then we're going to do some planning for where they're going to have next interim and maybe ways of working as well. Anyone want to agenda bash? Great. Let's go forward.
I have the power. Richard Barnes, one minor agenda bash. Since I think Imad is not going to be here until the Thursday session, I might propose taking the simplify key schedule thing, which is one of his big careabouts, and moving that to a Thursday, and moving the identifiers discussion up into that slot, which I think I sent you slides for both.
Simplify key schedule and decouple identifiers.
Yeah. So I'll do the decouple identifiers thing in the slot I've got there in the protocols discussion.
Okay. Yeah.
So the interrupt call synchronizes. All right, Richard, come on. If you want to come back up and give a summary of the interop call.
Yes.
All right. So we get for having the first session after launch, you have to turn on all the equipment again. So just a brief interop update. We have 4 or 5 implementations going. Raise your hand if you have an implementation of MLS in progress. Oh, is that Diogo there? Excellent. Cool. Good to see you. So yeah, we've got Cisco, Wire, Google, Trail of Bits, and INRIA all doing implementations. The approach we've been taking right now is kind of operating off generating test vectors for different chunks of the protocol. So we've got test vectors for the tree math, for the resolution algorithm, for the key schedule, for the core key schedule, for the application key schedule, and then for some of the message parsing. So that's kind of the framework in which we've been doing interop so far, not doing kind of live interop between stacks, trying to kind of gradually work our way up to that by getting the agreement on the core parts of the protocol. So we had some calls you may have seen scheduled on the list. The first couple of calls we had, we realized that it wasn't really useful to do kind of real-time interop. We used those more for kind of planning this and establishing this framework, figuring out what worked and what didn't. And then we've been doing a bunch of offline people refreshing the test vectors and testing against the test vectors, debugging issues, identifying issues, interop issues through the wire channel, kind of async style, instead of doing kind of live interop events, big bang interop events. And so We have, I believe, linked from the implementations repo, an interop matrix now where we are marking compliance, where people are agreeing on the test vectors, and we're starting to have a fair degree. Waiting for Diogo to report on something. He's the laggard here, but we have at least the Cisco and Trail of Bits and Wire implementations interoping, and I think Benjamin, you reported some recently as well. I saw some green in there for you. So we've got a fair, some slots in the matrix filled in, so we're starting to get some interop on core parts of the protocol. I think the tree math and resolution stuff that doesn't involve any crypto, like that, people have developed their own implementations, and then we're agreeing on that by and large, and then we're starting to ratchet up and verify that real crypto stuff starts to match. So by the time we get to the interim, I think we get 04. People upgraded to 04, and we should have some real interop going. Questions about interop? All right, thanks.
Okay. Now I'm going to do a quick summary of the interim. So the interim meeting we had between the last IETF and this current one was held in Mountain View, right next to Real World Crypto. So we did get some other interested parties who were in adjacent conference for Real World Crypto who showed up, and there were some pretty substantive conversations, presentations about the encryption of welcome messages, add in place, lazy handshake messages, proxy re-encryption for server assist, user initiated add, a brief update on analysis, as well as definitely some conversation about efficiency. And one other thing that was brought up that we will talk about here is the possibility to have a federation component and a federation milestone, as well as a document that Imad has published as an individual draft that should be coming up as well. There were also alternative tree math proposals made, one of which was about a 2-3 tree. So we'll see if that results in a draft being sent forward to be discussed here or not. But I have not seen that yet. And it was a pretty great event because all the people who did show up participated, and there was a lot of conversations. The notes are available on the data tracker for this. Okay, so any questions about the interim meeting? Great. All right, let's move forward to outstanding issues in the protocol. Oh, sorry, architecture with Benjamin first. Yeah. Yes.
Can you just go back for 1 second? Is that lazy updates or lazy updated, something I haven't heard of before? Okay, good.
There's a typo, we'll correct it.
Okay, so I'm going to quickly discuss about the architecture stuff. Basically, nothing has changed much since the last few interims, because we focused a lot on the protocol document. So one thing that changed across both documents is the fact that we aligned on the architecture document terminology instead of the protocol one that was using something called participant. So now everything is using client, and the protocol document was moved to reflect those changes. So we really have like we had before, A1, 2, 3 are clients owned by some users, and they are members of a group, while C2, for instance, is not a member of the group. So since there are not too many things to say, I just took the slides from IETF102 when we had our explicit requirements and goals, and basically we can see that most of the things we want, we currently have. Typically, messages are accepted only by a member of the group. Message padding for traffic for protecting against traffic analysis has been optionally included in the protocol document. But since that's still a high-level architecture goal, data origin authentication with the authentication of everybody through the authentication service that we still keep abstract, nothing changed, so that you can do whatever kind of authentication you want. The one thing that's going to be discussed probably on Thursday is deniability, because actually many people want some kind of deniability, and it's going to be very interesting to discuss what we really want or not, and we'll see. And well, all the main security goals have currently in the protocol document. We suppose there are, we don't have a proof yet, that ongoing progress, but we think that we respect those properties, so it's good. Scalability, we have experiments that show we can actually scale for 50,000 clients. It's going to be interesting to see how it really works real life, on the network. Asynchronicity, except for the group operations, which are like strictly right now in the architecture draft, the delivery service actually say that they are ordered. And we might relax that condition for update messages. We have actually interesting discussions on list with causal trichem. State recovery is something that we didn't really look at it yet. So that's one big point that we need to look at. And metadata protection is ongoing work. The common framing will discuss this a bit more Thursday, I guess. Federation, obviously in progress, and versioning is something that's going to be discussed as well. So the previously open question that we actually didn't look at, frequency of the key update, I think that's something we'll have to, so the idea is that we would recommend an update frequency depending on the number of people in the group, etc. And that I think we need real data to be able to actually do this kind of recommendations. There is ongoing discussion on whether it should be whether we should do subtrees in TreeChem for doing protecting the number of devices, etc. So that's also something that's being discussed, but nothing settled yet. And requirements on the server side for when the server helps is something right now. In the current spec, both the architecture and protocol, the server doesn't know anything about the group's membership. It might change depending on if we add server assist or not. So this is the current questions. Concurrency of group operations, I talked about it. Metadata retention, there is an interesting question that's probably going to be discussed by Raphael about the fact that in the key schedule, when you pick the key to decrypt application messages, you have the sender in the clear, which is not the public key. It's a strong identifying identifier, but it's like at least the index of the position of the sender in the tree, which is might leak some metadata. For some people, it might not be acceptable. So we are going to discuss this as in the common framework as well. Ephemeral signatures and deniability. Sophia will talk about it on Thursday. So on the editorial point of view, since nothing has changed in terms of security guarantees that we really want for the architectural draft, the editors will do a round of actually trying to make precise the text way more precise in terms of security guarantees that we want to achieve. The architecture document is quite high level for now. And I think it's a good idea that we actually spend time to detail way more all the informations in there. So we'll between now and the next IETF, we'll make sure that this is way more strict and thought in depth. Obviously, there will be the changes due to the existence of the federation document. We might actually outsource to the federation document some constraints or not, or include some of the federation constraints inside the architecture document, and we'll see that later. I think that's all. Nothing much happened recently, except.
No, so we just need to kind of make sure that we pick the pace up on the mailing list, i.e. sending messages to the mailing list. So what I'm hoping is that we can do is when you put an issue in GitHub on this, is that people can, discuss it there as well as on the mailing list. And we'll try to do a better job of actually driving these 4 new questions to ground and making sure the editorial stuff is done, because at the next IETF meeting, I would like to be in the place where we have no outstanding comments on this draft and we're actually ready to working group last call it. Now that would be a working group last call, not necessarily the final one, but it would at least kind of like give people motivations, I guess, to actually put their eyes on it and complete the reading of it. So, because I think it's actually been fairly stable. We just have to, once we get the terminology straight, which was a really funny discussion, but once we get it straight,
like the terminology is already in the protocol.
Yeah.
So it's like it's settled across drafts.
So I think that's really good. So great.
So that's it for me.
Now it is Richard. No, that one. This one. So you're going to do summary.
Just as the note taker, I noticed that the slides are not uploaded on the data tracker. I'll refresh to make sure. Just wanted to make sure that the plan was for them to be there because I did not include any of the contents of that presentation in the notes.
You were correct. I did not put his slides up
10 demerits to the chairs. All right, so we are currently on draft 04 that was published shortly before the meeting due to some hiccups with the deadline and approvals. So I'll forgive you if you haven't done a real thorough read through. So I'll provide a summary of what we did since 03. 03 I think was published right before the interim, so it's been a couple months since we've revved. Then we've got a couple of open issues, I think all of which have PRs, most of which have PRs ready. And so we'll kind of present what the proposals we've got sketched out for these various issues and solicit input from the community. So changes from 03, bunch of relatively small stuff. So Ben, I'm very grateful for Ben's, looking through and thinking carefully through what the terminology should be and making sure it was all aligned. So that's all aligned now, consistent between the protocol document and the architecture document. So that's good. There were some things about the application key schedule in 03 that were ambiguous, and so we got those cleared up and kind of clearly defined. So now we have something we can target for implementation. We've got some interop already in 04. We've changed now in this version from using ECIES in kind of a custom defined in this draft framework to using a framework called HPKE, Hybrid Public Key Encryption, that Karthik and I have submitted to CFRG. We'll be talking about tomorrow morning. Anyway, sometime this week, whenever CFRG is meeting this week, we'll be presenting that draft, proposing for adoption there. The idea is to have kind of a reusable ECIES-like primitive that could be used in this protocol, in ESNI and the TLS context, and a couple of other contexts where that's useful. So we went ahead and submitted that draft, and so we changed the definition in MLS to use that now as well. We've got some version negotiation stuff in there, which we've got just a very shim thing in 04 that we'll have some more discussion about today. Added a hash of the welcome info in the ad, which there was a thread on this on the mailing list that 03 had some authentication vulnerabilities due to there being not enough tying between the welcome message that is sent to the new joiner and the ad message that announces into the group. So adding, in the Tamarin model I did, which, I am not a Tamarin expert, but I think it was more or less correct. In the Tamarin model I did, having a hash of the welcome info and the ad message was enough to address that vulnerability. So hopeful that the academics in the crowd can help build some assurance around this. I think it's at least a step in the right direction. And then I'll take two topics I'll talk about here are key separation within TreeChem that Conrad Kobrook proposed, and some this question about garbage collection that we addressed at the interim and kind of finalized in 04.
Just hold on back for a second. From a chair perspective, right? So the HPKE stuff actually does introduce a dependency, right?
It does introduce a dependency.
Okay.
My hope is that, I was just talking about this with Karthik, if we can get this if we can get CFRG to adopt it now-ish, it's a pretty consolidated piece of work. So my hope is we can work it through CFRG expeditiously and not cause any delay for this work. Yep. Okay, so Key separation within tree chem. So in earlier versions of tree chem, right, you start with a leaf secret and you hash up the tree, and the secret value of the parent node is the hash of the child value. Conrad pointed out that this means that you now have some relationship between the nodes in a direct path, which I guess is kind of unfortunate. It made the academics unhappy. Britta's nodding here, so I assume that academics are unhappy about that. And we try and keep our academic friends happy here, so this seemed like a low-cost way to do that. So instead of having this direct relationship between the nodes, what we've done instead in this version is we kind of derive these ephemeral secrets, which are the dashed lines here. We start from this secret value and KDF it over to the leaf value, but separately KDF its successor value and KDF over to the node, so that once you've done this, you can throw away these values, and once those values are gone, there's no evident relationship between the things in the tree. So you have more independence of the values in the tree.
But you still need to be delivered the things in the dotted boxes, right?
Yes.
Okay, so you can verify that the tree's constructed.
Yeah, exactly. The idea is that instead of delivering the secret values of the nodes, you deliver the things in the dotted line boxes. Yeah.
Thanks.
Yeah. Any other questions or comments on this, Catriel?
Catriel, you only deliver the bottom box, right?
No, so it's in tree chem style. Actually, the bottom box doesn't go anywhere. So in this case, the second dashed box would be encrypted to this guy, and the third dashed box would be encrypted to that guy.
So the up arrows there,
same pattern as tree chem.
the up arrows there are not hash. They are morally related to.
No, they are.
Yes.
They are.
Okay. Got it. Thank you.
Yeah. The bold arrows here, the solid arrows are KDFs. I forget whether they're just hash or whether it's some sort of some chunk of HKDF. But yeah. Okay. That's that. Finally, this garbage collection topic, which we've talked about a few times. We discussed this at the interim. There's two cases here. You want to be able to add people in place, which is fairly straightforward. You just add them in a slot and blank out their parents, just like you do if you add them on the edge. The thing that was more controversial was removing people and garbage collecting when you remove. So the scenario we've got on the right here, the idea is we've got this tree where we used to have 6 members. These 3 intermediate members got removed, and we're left with the 2 on the left. And now we're going to remove the guy on the right-hand side. And we'd like to clean up the rest of this tree so that we only have the little tree for the 2 members. And so the algorithm that's in the doc now, which is what was proposed, what we discussed in the interim, you just, when you delete this last member, you delete nodes from the tree until you get back to a non-blank leaf. And so you delete everything to the right of that leaf when you delete the rightmost or delete a member that's the rightmost non-blank member. That's the algorithm. When we discussed this at the interim, we kind of decided, yes, this kind of looks good on the face of it. If we can convince each other that this tree invariant still holds. So remember, our tree invariant is the thing we spend all our time trying to keep, which is that for every node in the tree and for every member in the group, that member holds the secret for the node if and only if it is a descendant of that node in the tree. And so my one-line argument here is that, given that definition of the tree invariance, if you simply take a subset of the nodes and members, which is what we're doing when we throw away the tree, that invariance still holds. And so the tree invariance still holds, and so it's okay to do this this garbage collection in this way. So given that kind of loose argument, we went ahead and landed the PR, and hopefully further, deeper analysis will bear this out. Anyone have remaining concerns about that? I feel like Jonathan Hoyland is making skeptical faces at me. All right, so that's the status as of 04. Any further questions, comments on the current draft? Jonathan?
John, thanks. I just have a question. I mean, I believe that this invariant holds. I'm just wondering if this is sufficient to actually do garbage collection and real life? Are you actually going to get in that situation where you have significant numbers of blank left nodes as opposed to just a random distribution of blanks across the tree?
Yeah, no, it's a fair question because, and it's hard to say because, groups in reality are sociological things.
Yeah, but I mean,
so I think the idea is if you pair this, one other thing we discussed is the ability to move a member from one leaf to another. And you notice if you combine remove with add in place, you effectively get a move operation.
right.
And so I had sketched something out at the interim about doing that as a combo operation.
Yeah. I mean, there
which we
needs to be
decided
some
not to
sort of
do.
organized way of making sure to, compact before garbage collection.
Yeah,
in
so
general.
that's possible. It's just, a thing you'd need to, the application would need to coordinate given a certain view of the tree. So the crypto is there. It's just, you need some coordination to make it actually happen. Yeah, DKG.
This is DKG. Do we have any sense of how frequently this sort of thing is going to need to happen? I mean, we're talking about actually being able to do this kind of cleanup. Like, I think maybe we should push off this question about efficient compaction and garbage collection. Like, it seems like we don't even have evidence that this is a problem for a deployed scenario. So I'm happy with just having remove and add in place and not trying to make some sort of fancy compound argument.
Yeah, I agree. That's kind of why we started with what we did, just defining, updating the remove operation so that it garbage collects when you do remove. I think in practice, you'll be removing, like, you'll be GCing 2 or 3 slots, maybe on a given time. But yeah, if we find in practice that, you need to do some compaction before you garbage collects, I think that's something we can do plausibly as a follow-up or handle later. And since we know the general outline of what you need to do. All right. Nothing else. We'll move into new issues for draft 05. Oh, right. All right. So this was another issue we discussed briefly at the interim. So I want to highlight here side by side the identifiers we have for cryptographic things in TLS and in MLS version 04, the current version. Right, so as usual in IETF protocols, we have pluggable primitives and we have identifier spaces that identify either single primitives or combinations of those primitives. And the trade spaces, we just have to decide, like, to what degree do we want to have a single identifier that identifies a whole combination of primitives, and to what degree do we want to make the primitives plug and play. So TLS has kind of gone back and forth on this. Early in TLS, you had cipher suites, which defined a single value, defined all of the algorithms in use. And now in TLS 1.3, we've decoupled that a lot more. So you have separate identifier spaces for the signature schemes in use, the DH groups in use, and the cipher suite now just identifies the AAAD cipher and the hash function that's in use. That's the only combination that's there. Current version of MLS is a little bit more aggregated than that. So we have signature schemes broken out. So you can use, say, ECDSA together with X25519, but the curve, the hash function, and the AEAD function are all together in one identifier space. So that one value defines all of those things. And so the question is, I think Ecker proposed that we split this apart, that we would have better experience with evolvability of the protocol if we had these broken into separate things. So the general question is, kind of what groupings do we want to have here? So the first line here is what we have right now in MLS, where we have the DH group, the AEAD, and the hash all together in one identifier space, the signature in a different identifier space. The second line here is what TLS has. We have the groups in one space, AED plus hash, and the signature space. The third line is one that came to my head. The thing that is concerning, that is potentially concerning in the MLS context, is that we are using the hash function to derive DH key pairs or chem key pairs for whatever we're doing in whichever chem we're using to do tree chem or base chem. Right, so you, for instance, if you're using ED448 or P521 in a high security setting, you might want to forbid the use of SHA-256 as for deriving key pairs to that, because you end up in some like low entropy subspace of your big curve space, and you're not getting the full benefit of that curve. So was that? You might. I'm just proposing you might want to match these things up. It seems bad. Like the numbers don't match. So.
I mean, I guess, but I mean, presumably you mean you're like, you know, you have a 256-bit hash and a 1,000-bit EC key, because the 256-bit hash has corresponding strength to a 521-bit EC key, plus or minus, right?
Fair enough.
I mean, maybe like a, you know, a 260-bit hash is what you're looking for.
Yeah. So, I mean, I think we can do any one of these. Like the usual concern here you hear is phrased as level matching here. Like, is it okay to use P256 together with AES256, which is gonna, so you're getting more strength but weaker keys going into the AEAD. You know, TLS has decided that this is not worth pursuing. Like you can have that combination with TLS.
Yeah, I mean, I think that, can you go back to your previous?
Yeah.
I mean, so I mean, it's worth noting that if you actually had a level matching theory, then what would you use the cha-cha?
Right.
And the answer would be P521, perhaps. I don't think a level matching is coherent, never has been. I think that there might be some there was some crypto reason why you want to have a much larger hash with a large group, but I don't think entropy is the answer, unless Carfax can correct me here. You know, maybe you want it wide or something. But my impression was that these things could be made to go arbitrarily wide if you structure it properly.
What do you mean by wide here?
Like if you need for some reason, because you're going to need to generate more than 256 bits, right? But each KDF can generate as much data as you want. So I think it's probably okay. Certainly we treated it like it was okay in TLS. And I think that certainly as far as matching, I mean, can you go back to the next slide now? I guess I don't think there's any sensible level matching story about the group in the AEAD. That just doesn't make any sense to me at all. I think that maybe there's some coherent story about the group in the hash, which I'd defer if CFRG told me to. I would defer to that. But I think that the second two are the right set. I think I think that if I were to do group in hash, I would do what we did in TLS for signatures, which is basically to commit to one hash for each group.
So how is that reflected in TLS?
Oh, so if you look at the TLS signature things are named as if there was some as if they're mix and match, but they're not really. Namely, you can't use SecP256K1 along with the SHA-384.
So you're saying, yeah, that ECDSA with P521 is locked to P5.
Yeah, we just didn't define code points that were like that. And you can see that in EG25519, which has an implicit hash, but we don't say what it is, right? So the only reason this first one's named this way is because it used to be you could mix and match them, right? So I think that if you wanted to do so
that means there's a degree of consistency in this third option here, right? In which each thing is nailed to a hash.
Right, exactly. I'm just saying that I woun't build the combinatorial support explosion of things. I would just be P256 is user SHA-256.
Yeah.
But I guess I suspect you're going to end up with so curve 448, you're going to use a SHA-384, or you're going to use a SHA-256. I guess I would just pick one. I don't think you have to try to
Yeah. Right. So the question, I think the major question here is whether people are concerned about, shorter hashes being used with bigger curves. And if that's a concern, then how we want to constrain it. You could constrain it by just saying in the definition of how you use the curve that it has to be used with a hash function that produces at least X bits of output. And you handle that at the application layer. Or you could define these combined group plus hash, kind of nail it up that way. Do people have opinions about whether this is a problem, and if so, how to handle it? Martin?
Yeah, Martin Thompson. Oh, that's good. It may make sense to have a look at the actual units that you're dealing with in the protocol. So that the DH component that you use for this is one thing, and the ECE whatever the thing is that you're using for encryption is another thing, and the AEAD is another thing entirely. So rather than saying, oh, we have these groups and we have these hashes and we have these AEADs, have a look at the pieces of the protocol that act on this. So you have a KEM, and that KEM comprises of the following group, and maybe you need to hash to the group, so therefore you need to pair the hash up with that, and that sort of speaks to the last one, I think, to some extent. And the last one is just we're just talking about protection of messages once we have keys. So think about it that way more than you think about it.
Actually, that argues toward the first one, because when we're doing KEM, we're doing ECIS, which means you're deriving, you're
Right.
doing DH, you're deriving, and then you're plugging it into AEAD.
Right. So if you have a unit that does all of those things together, then maybe you don't need to split things out as much.
Well, I mean,
So in particular, this is unlike TLS. Well, it is like TLS in that AEAD is presumably getting used for application messages, but the KEM usage is unlike TLS.
right. I mean, at some level, like you might doesn't argue for one. It argues for one prime, which has a third, which has a second entry in between the first and second entries called AED.
Yeah.
Where that represents the message. Is
What are you
AED.
talking about? What you do the bulk encryption with? Yeah.
Yes, exactly. So I think if that's the module now, I think because HP key is new, we don't really have to deal with this question of whether people are whether people have orthogonal AEDs to their grouping AD. But I certainly don't. I guess when I argued about this in the interim, my complaint was I don't think you should tie the bulk encryption to the key establishment. I think that the key establishment, if it really turns out the key establishment is much more convenient to tie all this together, fine. But I think you shouldn't tie them together with the bulk encryption.
Yeah, and I think that's probably a major point to capture here is we might need 2 AEAD slots. Yeah. Okay. All right. Well, I think this is good feedback. I will go back and I'll ponder. It's not immediately clear to me standing here which of these, what option all of this argues for, but I'll revise the PR and send it out to the list, and we can make a decision. All right. I think it's over to Raphael. It's nice that we all randomly decided to use the same template.
I know, I did notice that.
All right, so next we're going to talk about the server-initiated removal. And just for context, that is something that has been requested by some vendors. So just to understand what it is, some vendors have made it quite clear that they would like to use MLS, but with the server knowing what the roster is. So the server knows who's in a group. And in that scenario, they wanted the server to be able to remove someone from a group. So this means that we've been talking about the server, but really it could be any external party. It could be an administrator or something in a different context. And so we started with one proposal and then added another one, and I'm going to briefly explain both of them.
So one second. So the rationale was for server initiated remove, but it's because the users were inactive, right? I mean, it wasn't just hey, I want to kick that guy out.
That is one scenario, but not necessarily the only one.
Okay.
So for example.
Ecker said because he's fired.
Yeah, because a lot of these things are corporate systems, and so someone gets terminated and you wish to put them out of the group, or as someone said, they don't put their bill. There's lots of reasons for managed systems to want end-to-end security, but still want control of this in the group.
Yeah, that's a very good point. So the first one, just to recap, was inactivity, to the extent that the server can actually monitor the inactivity, which is not quite clear yet. That would be one reason, and then manage environments and corporate environments is the other one. Or maybe simply for consumer messengers, if somebody closes their account and therefore cannot do any crypto anymore, there needs to be a way to remove that person as well. So first proposal, under the codename of external remove. So the external party, meaning the server, can send a handshake message to the group. And that is, of course, not encrypted under the group secret because it is an external party that doesn't know any of the group secrets. But that message would have to be signed in the same way that handshake messages are currently being signed, except it will be signed by an external identity. And so that is precisely the problem. It's not quite clear what that identity is, how that is being managed. So none of that is currently linked to the group state we have. The group state really only contains the identities of the members of the group, but nothing else. So that raises the question, how can a client trust this signature at the end of the day? And more importantly, how can all of the clients trust it? Because in order for this to work in a robust fashion, all of the clients would have to come to the same conclusion that this is a trustworthy signature and would remove a person from the group. And now the question is, these external identities, are they going to be managed? That seems to be completely out of scope for the MLS protocol at this point. The assumption is that it might have to be dynamic because groups don't have any restriction on their lifetime. So you could probably assume that the server identity or whatever it's going to be might change over time, might need to be a revocation mechanism. So the worst case we're looking at is that if there are some clients in the group that will trust the signature and others don't, and some of them will remove a participant and others wouldn't. And then we have partition of a group, and then we have a problem, essentially. Is there a question?
Ben Kadek, yeah. So I'm not entirely convinced that the clients all have to agree on who to trust, but perhaps we don't like the other options. I mean, you could say some scheme where the external entity sends a external remove message to all of the group participants. And if any one of them trusts that external participant, they then like proxy that message, sign it.
Right. You're too quick. That's the only thing here. So that's going to be the next slide.
Thank you for the segue, Mr. Kadek. Yeah, I think the upshot of this one is that if we wanted to have this, then we would basically need to extend what is now the group state, that is the thing that everyone agrees on via the key schedule, and have additional things that the group has agreed on in there, and include information about the authorized external parties there, which is doable, but I agree is probably not worth the trouble.
Yeah, I mean, we could certainly try and get a list of those external identities into the group state. However, if it is a requirement that this list is highly dynamic, then it might not be good enough to just have it in there, because it might change in between. So if the epoch never changes for whatever reason, because the group is completely inactive, but you have a change to the identity list, then you do have a problem.
So, I mean, just so I'm clear on the behavior here. So we have a group of, 4 people, and some server sends an evict individual A, and B and C trust the server and D does not. Then now you end up with basically D ignores the message and B and C take it. And now you have a partition, right? But they know they have a partition because they have a different group structure, right?
I'm not sure if they know about the partition at that point.
Well, I mean, they can no longer send message each other because they
find out the hard way.
Yeah, right. I'm not sure. I mean, hopefully, I'm guessing in fact this is proposal 1 means your proposal doesn't know this problem. But I mean, I think I can live with that property. So,
Catriel, can we punt on the external identities to the application layer? And just say, if Wire wants to instruct foo to be removed from a group, Wire must figure out how to tell all of its clients to do that.
Right. That could be one assumption, yeah.
I would support that over having to include external identity management as yet another thing we have to do in the protocol. But let's get a proposal too.
Right. It's not quite clear. So if we have external identity management or something similar, it doesn't mean that it has to be inside the protocol, but it has to happen somewhere. So we can debate about whether it's application layer or not.
So that can be like proposal 3.
Okay, let's look at proposal 2, and then we can debate some more. So the idea here is that the server or the external party sends a request to the group that somebody should be removed. And then probably the first member to come online and to see that request will honor it by actually removing the member in question. And so that would be done through a normal remove handshake message, which is not ambiguous because everybody in the group is going to follow up on that. The only thing that is slightly strange at first is that, say, if Bob was the one to be removed, with a normal remove message, the user interface of the messaging system would typically say, Alice removed Bob. Whereas in this case, it was requested by a server, so it would have to be surfaced slightly differently to the user to give some more context of what happened here. And that could be achieved by somehow including the remove request that came from the server so that other clients can interpret what happened correctly.
Unfortunately, it's not just that. So many systems have, group systems have 1 or 2 group administrators and no one else can do kicking or removal. And so in those cases, this simply won't work at all. In those cases, you're basic, unless the admins are the ones to do it. But I mean, like often they're like not online all the time, right? And so you get very, very slow removal, if any. So this seems like only a very partial solution.
What is your concern? In which scenario wouldn't it work?
The scenario is you have a group of like 200 people, right? Mm-hmm. And there's 2 people who are administrators, and only administrators can evict people. Oh, okay. And so, like, you know, like to go back to my example, right? You know, I'm fired, and they want to, and I'm supposed to kick that out of every group in the system, right? But it turns out like that the admins for those groups like are on vacation, and so like nothing happens. And so like that's like a really non-deterministic behavior. So I think the problem is any system that wants forcible removal as opposed to just like people who are like, you know, who are just like not idle, like is going to need to effectively have version 1, not version 2.
Okay, yeah, that's a fair point.
This is Daniel Kahn-Gilmore. I'm just observing that your proposal for how the UX UI change would look seems super problematic to me. Like you wouldn't want to actually say that, wouldn't want to remove the picture of Alice being the one who does the removal if this proposal goes forward. I mean, yes, I agree with you that you would need to, that it would be reasonable for it to say Bob was removed by Alice at the request of the external party, but totally eliding the fact that Alice was the agent of the action would be a mistake.
Yeah, I mean, I'm not proposing a specific copy here. All what I'm highlighting is that just saying Alice removed Bob is not the whole truth in this context. And we do have the chance to improve the copy.
So yeah, we have the chance to improve the copy, but it is actually the whole truth from the perspective of the rest of the protocol.
Yes.
Right. From the perspective of the rest of the protocol, it really does, like, it is still Alice who's making that call. And yeah, we can offer some additional cryptographic justification, but we could do that in many other types of removal contexts as well if we wanted to. Alice could say, I found this CRL online that convinced me that this person needed to be removed or something. I'm not saying we should do that, and I don't think we need to bake it in.
It's Catriel again. Just to push back on what Eka said a little bit, because who can remove is only an application level policy anyway. As I understand it, anyone cryptographically can remove anyone, and the application will enforce, well, Alice wasn't actually allowed to do that. And therefore, you could have a policy that said only the admins can remove somebody unless they attach an extra remove request message, and then you should process it.
But I thought maybe I've forgotten, but I thought that like you didn't need to issue the remove request cryptographically. You didn't need part of the group either, do you?
No.
Right. So I mean, so I guess I don't understand. Like this entire story is about like authorization of the request, not about the formation of the trait.
So yeah, I think the premise here is that the remove request is authenticated from the vendor, basically, right? So okay, so
my point is like it's just a signature propagation problem.
Yeah, absolutely. But I think what Catriel is saying is, you're presuming that the remove policy that the app enforces is these 2 admins are allowed to remove and no one else. I think what he's saying is that you could have a policy that says the people who can remove are these two admins or anyone in possession of a remove request.
I understand, but what constitutes being a remove request? And what constitutes being a remove request is signed by the vendor. So like now we're just back to part one.
No, well, no. I mean, the remove request is at this in that framing is basically a capability token, right? Like you've provided a capability to everybody to evict just DKG.
What is the structure of that capability? But I mean, but one again, yeah.
So maybe taking one step back, in my mind at least, proposal 2 is basically saying all of it should be solved on the application layer. We don't touch the protocol as such. People are effectively being removed with a standard remove handshake message. But the rest needs to be done on the application layer. Whereas proposal 1 would potentially mandate that we change things in the group state, meaning we effectively change how the protocol works.
I mean, let's like I think I actually kind of liked Catriel's I think it was Catriel's question earlier, right? It's like we're like all running wire, and like that wouldn't that be great? And presumably we're all like connected to the wire update channel for like tells me to get a new version of wire occasionally, right? And so so wire could just perfectly well send me a message down that channel that says like, listen, like this guy's been kicked out of the system, like take every group he's in and pull them out, right? And every user of the system automatically regroups the tree with this guy out of the system, and that's like, so in some respect that's out of band from the protocol entirely, right? I mean, they like everybody just sort of spontaneously, from the perspective of the protocol, everybody spontaneously removed like Daniel from the tree, right? So I mean, so in that respect, you can certainly take it. You can certainly not like you don't have to define protocol messages for it, I suppose. But I think like let's distinguish between like from a sort of a tree machinery perspective, this person has to be pulled out of the tree. From like an application perspective, you get authorization meant to tell you to do it, and like we could define that here, or we could not define that here, and that's kind of like a separate question. But I think from a tree perspective, he's got to be pulled out of the tree, right?
Well, the question is also in which order that happens. So everybody has to do it at the same time, at the same epoch.
Right. But I mean like so like okay, well like because but you have your right. So I mean it's complicated, right? But in the case of wire, because you control both the fit messaging server and the update channel, it's like pretty straightforward, right? You like say like the update channel, you say like look at this level at this point, like pull them out, right? I'm saying that systems which are both centrally which are like a one monolithic system that have like that have like one administrative system as well as one one software vendor like have that property, right? I'm not advocating for it, I don't think. But I mean, like even a delegated, even a system which is a more open system that has like but has some central group manager still has the same property, right? I'm just saying like that the thing the application needs to know is like someone is authorized to tell me to do this, told me to pull this person out of the group. Okay.
But I mean, just to summarize, so that is completely on the application layer, what you're proposing. So this doesn't mandate any change on the protocol layer.
Yes, at some level. Is there a proposal for you, by the way?
No, not from my side.
Joel Alwyn. So correct me if I'm wrong, but isn't it true that when there's an update, we also have to refresh the secret? We have to add new entropy into the secret, into the group secret, right? And so my concern is where that entropy comes from. And I prefer proposal 2, even if proposal 2 requires an identity, a cryptographic identity for the server, whoever initiates this removal. Because if we go with proposal 1, and we actually let the server do that, then we're asking the server to provide that entropy, which gets mixed into the new group secret, and we don't want that. I mean, I don't think that's the right way to go. I think it's better if that entropy comes from a user. So I actually prefer proposal 2, despite it still probably being better to have cryptographic identity.
Yeah,
So-
that's a good argument. I mean, we never took it that far for proposal number 1 to think about where new freshness comes from. But I guess you're right about that.
Yeah, which also means that even if we have a way to synchronize through some external channel, and so everybody in the group realizes, okay, now we have to remove Bob, there's still the question of where that new entropy comes from. And I think the only source that makes sense to me is somebody who's already in the group, who's privy to the group secret. We shouldn't be taking entropy from outside, basically. So that's why I like proposal 2.
Good point. Yeah.
Yeah, Richard Barnes, I sympathize with that, but it doesn't seem like catastrophic because whatever entropy is being provided is being KDF together with entropy that's secret to the group. Yeah.
Now the update doesn't refresh it.
Yeah. Yeah.
Please repeat the question or come to the mic.
So my reasoning behind why I think this entropy should come from members of the group is because in a PCS scenario, so suppose you have the adversary's corrupted the server and he corrupted one of the group members, he knows the state now. If you allow the server to also add the entropy during the update, it means now the adversary effectively knows both inputs to the KDF, and so he knows what the new state is. So the refresh didn't do its job of cleaning out the state and kicking the adversary off the channel. So that's why, I wouldn't allow it from any external party who could then potentially be the adversary. I mean, yeah.
Okay, thanks. Yeah, so that's a good point. I think that argues pretty strongly for proposal 2 here, having this be done within the group by a group member. A bit on the authorization question, I grant that there are similar authorization problems here to proposal 1. But actually why I got up here is to try and argue that even those authorization issues are equivalent to a previously unsolved problem. Namely, if you have any non-trivial authorization policy on remove, any policy other than anyone can remove, then if you're assuming that everyone is synchronized on that policy, or else you have this fragmentation risk. So adding one more bit to that policy, one more authorized key to that policy, doesn't seem like something super tragic in addition to what you already had to be synchronized on. So that seems like a tractable problem. It seems like this is kind of the protocol modality. I think that raises raises the question of what the protocol impact here is. Do we need to define the remove request? Do we need to define what this capability looks like? Do we need to define a slot, an extension point where it could go?
So my assumption so far was that the remove request doesn't mandate any specific changes to the protocol. I mean, we might still want to write it up as a guideline, basically, of how things could be done, but it fundamentally remains an application layer solution. And since we don't standardize those, I saw it as outside of the scope, but yeah.
Okay,
obviously up for debate.
So basically, this proposal doesn't result in a PR to the protocol document.
That was my assumption, yeah.
And the idea is, in order to get your remove message accepted by your peers in the group, you would glue on the outside of it a token that says this is okay.
Optionally, yeah.
Yeah. Okay. Yeah. That makes sense to me.
Go to the next slide to
Britta Hale.
That will answer.
I completely agree with the observation about new entropy, but I want to say one comment on the proposal 2. I think we changed slides there, but if we go back. So one comment about the proposal 2 is that the server cannot actually enforce a removal of any group member. So whereas in proposal 1, they can.
That's a very good point. So what you're saying is that the group could boycott whatever the server is asking.
Exactly, yeah. So it's up to the group members then to decide whether or not.
But that is also true for proposal 1 to some extent. People could do it individually, leading immediately to partition, obviously, which is even worse. So that's a very, very strange threat model that we haven't contemplated yet, where basically clients do whatever they want and they don't follow what the server says for these things. So I see it as being a problem in both proposals.
This is DKG. So the if the server isn't prohibiting the client that they've kicked from contacting the others, then there really is no way for the server to actually defend, to enforce that this member can't participate, right?
In both proposals, yeah.
Yeah, I mean, that's just the nature of how these things are fit together.
I agree, yeah. So, maybe to go to the last slide, what is connected to that a bit is that with proposal number 2, it appears to not be in real time because it's a request that's being sent out and nobody knows really when that is going to be enforced. But that would have to be a rule on the application layer, essentially, that you don't do anything before you haven't honored the remove request. But MLS is fundamentally asynchronous. There is no real-time element in it by design. So I don't think this makes much of a difference. It's just maybe more of a psychological feeling that things are not being enforced immediately.
So this is DKG again. As far as the motivation for this entire question, will a server operator in any of these cases need to be able to say this action was done, right? So the server operator might say, oh, we need to kick this person because of policy reason X. Let me start the machinery and process that does that. Do I know that it's completed?
So
do I have a requirement to know that it's completed?
It's a good question. So the initial requirement here was that the roster is known to the server. So at the very least, the server would see a change in the roster there and could determine from that change whether or not the action has been completed. But
Go ahead.
Ben Kata, so if you have a sort of like policy or auditing level reason to need to be able to confirm that somebody was removed from the group, does that sort of force you into having a like auditing agent that is actually a member of the group?
It's a good question. I mean, so far we've never really looked into how managed groups with different, policy levels, clearance levels, whatever look like, because simply on the cryptographic level, everything is egalitarian, as Catriel said earlier. So all of that is something that again happens at the application layer. So we don't have a precise idea about that. The question is whether we need to.
So I think this argument about the forwarding like really conflates authorization with PCS. I understand that like if the server initiates this, the guarantees don't look as good, but people are going to key update and then the guarantees will look okay again. And so like gatewaying the deletion procedure on some group member reflecting it just like does not like feel like a non-brittle protocol design. I'd much rather have a situation where everybody immediately takes action on the deletion, and then there's some other separate operation which's job it is to like apply PCS for the deletion, just to feed new entropy into the system.
But what guarantee do you get from that? That stuff is being done immediately? What problem does it solve if everybody agrees on the rule that you don't do anything before you remove someone? I agree. It makes me feel better personally as well, but
maybe partly an aesthetic position, but it just feels like you're like taking two protocol functions and gluing them together in a really odd way. And especially the fact that like, I mean, it's like when Alice forwards it, that has like no meaningful semantic content about like it's like no meaningful semantic content about authorization, right? Like you need to so in the case where Alice is not an administrator, the only basis on which you're accepting this is not that Alice sent it to you. You're accepting it because it's signed by the group, by the root, right? Not by the root, but by the authority. And so so saying like Alice should forward it. Like, I mean, you might as well have why not instead have a rule that, upon receiving this, like you generate a key update of your own, but have basically the same effect, right?
Jonathan Lennox, you're saying about the knowing when it's complete is, does the requirement here, the roster is known to the external party, mean the roster, or the external party knows every member's view? Or that, you know, whether everybody's actually gotten the state update yet?
No,
Or
I mean, the
just-
roster is really only the list of members in the group.
I mean, what does the list mean when, you know, when not every member might know the list yet?
I mean, how the server gets that, I mean, it could be inferred if handshake messages are not encrypted, for example. That would be one way. But this seemed like the minimum requirement for server-initiated removal to make sense at
I
all.
was wondering if the list is well defined.
Ben Kadek, I guess I'm still sort of confused how this, the server sends a message and everybody acts on it immediately would work. Because, I mean, we do have sort of asynchronous message delivery, and doesn't there need to be something to enforce, like, that it happens in the same epoch? Doesn't the external thing need to know something? To put
I
in?
think so as well, yeah. I mean, there would need to be either some instruction at which epoch it should happen, or some other magic, which I don't know how that would work right now, yeah.
Yeah, and that sort of gets us back into whether the administrative agent that does the removal needs to be like a member of the group to some extent.
Yeah.
Catriel here. This might be a good one to take to the list, in particular, thinking about the threat model here. I believe a lot of this discussion is in the context of a malicious client. Is that right?
Not necessarily.
A client which is not following the rules and is choosing to not, well, if that were the case, pardon me? The comment was app layer rules are distinct from crypto rules. A malicious client that doesn't follow app layer rules could also tweet all messages. So perhaps we should think through the threat model.
Slightly more directly, like if the users in the group chose to were non-compliant enough that they all decided to boycott and either not do the remove or not process the server's remove, they could just as well do the remove and back channel all the messages in the group to the guy who just got removed. So I think that there's an argument, like if the users in the group are sufficiently bad, then there's nothing you can do to stop them from keeping the guy in the group virtually even.
Yeah, I think that's generally true, and we've found that to be true in other circumstances as well. So I think what sticks here is the argument of synchronicity, of how that can be achieved if it is on the application layer only and it comes as an instruction from the server. So how can we agree that everybody removes the same member at the same epoch? So that remains an engineering problem, yeah.
I mean, Jonathan Hoyland, Cloudflare, you could do fancy stuff with unsealing and proving that you have removed people from the group, just to return to the previous question. Like it is a crypto problem that you could solve, assuming that the clients were honest.
Right. The question is whether that is actually relevant in the context of MLS at all, or if that is something very vendor specific that a vendor wants to see.
Exactly.
Yeah.
So on the question of what we should do here, I think I'm going to come down on, as I often do, on the side of not doing work. It sounds like this. Oh, it's worse because I didn't even hear it. So it sounds like this proposal too, like punting it entirely to the app layer, can be done without protocol changes, just by doing some authorization stuff in the app layer. So I think I'm inclined to do that for now, like, and maybe, you know, make an issue on the architecture draft to describe how this could be done in the overall framing, but leave the protocol draft as it is for now. You know, that has the advantage that, you know, nothing changes. So if we decide we need to do something different in the future, it's not that hard to come back and do it. So that's how I'd be inclined to go.
Yeah, and I tend to agree with that for specifically the reasons you just said. If we want to do anything regarding proposal 1, we need a more concrete proposal with more details in it, and then discuss it. doing proposal 2 is basically doing nothing for now. That's true.
Well, if we want to go with proposal 2, then would it make sense to extend the message format for removal to allow a field for justification, arbitrary justification string defined by higher level application? That would be then also, that would have an effect on our protocol, on MLS.
Yeah, that's a good question. I'm personally not entirely sure whether we need it or whether we can do that again at the transport application level somehow and glue them together there.
Yeah, the reason you would need that in MLS is if you needed that to be signed by the member and then kind of unforgeable by the server, which doesn't seem like, if there's let's put it this way, like the server, if this is not bound into, if it's not done in MLS, the server can add or remove it at will, which means that you could have an implementation architecture where someone, the client is commanded and the server just adds this authorization on as it transits the server, which seems like a just fine architecture to me. So I don't really see the need to bind it into the protocol here.
Okay, so maybe then as an intermediary result, we stick with not changing the protocol for now until we have a better proposal on how to do proposal 1.
Does anybody want to get to the mic and argue strenuously for proposal 1? Great.
No, I'm not going to argue for proposal 1, but I am looking at Benjamin suggesting that he file an issue on the architecture to describe it there.
Yeah, that's good. Then we have it documented somewhere. All right, then we can move on. Version negotiation. So it is a bit of a luxury to think about version negotiation at this point, to the extent that we have maybe bigger fish to fry, but at the same time, it's something you want to think about early so that you don't paint yourself in a corner. So there is an addition to the draft 04, and it's a fairly basic one where we basically mimic what we do with cipher suits. And so clients can advertise what version they support in the user init keys. And essentially, in a very undemocratic way, the group initiator decides what version to use for a group, and then everybody sticks to that. And so whenever user init key is retrieved by the group initiator and somebody is invited, in the welcome message, the initiator indicates which version is being used. And of course, the downside from that is that if a certain client doesn't support a certain version, it's not going to be part of the group. So these are the concrete changes in the structure. And the user init key, there is simply an array of supported versions, and the same happens in the welcome info. So there are some open questions. I mean, so far this is rather straightforward. The major one is, should it be possible to ever upgrade an existing group to a newer version? And if that's a no, then the discussion ends there, of course. If it's a yes, then the question is how? And should that happen on the application layer? Should there be something in the protocol that facilitates that? And also, what are the security properties when you do that? Which is, of course, very hard to answer because we're working on version 1. We have no idea if there's ever going to be a version 2 and what it's going to look like.
Jonathan Lennox, I mean, I think you would also want the converse. Then if you discover, oh, hey, I wanted this person to join, but they don't support the new version, do you want to be able to downgrade existing groups to an older version?
That would be nice for the person, but it also sounds very dangerous.
It does, yes. And then the other question I have is, do you want, in addition to versions, also have protocol extensions that are not necessarily, all or nothing, but, we support also this additional feature, which may be, either, comprehension optional or comprehension mandatory, possibly having both.
Like in the capabilities that are advertised, where you would say, I support extension 1, 2, and 3, but
Yeah,
not 5.
something like that, yeah.
Yeah, I mean, that
And,
is something we've never really
and
talked
it might
about.
even be, I support 1, 2, and 3, and if you don't, that's cool, and I support 4 and 5, and if you don't, you can't join the group. They might have both categories of extensions.
Well, we don't really have the concept of extensions yet.
Never do at the beginning of the protocol.
So I guess my feeling with no hat on, though I'm sitting up here, is that it should be possible to upgrade. I have this vision of like a long-term group that's for a large corporation, and like new version 2 comes out, and you're gonna send out a new message to everybody. I mean, you're gonna make everybody in that company like, you're gonna do what?
Well, I mean, it's always possible to upgrade a group at the application layer by just throwing everything away and reinitializing the group. Right? There's no UX impact. Like, it's all just crypto nonsense that happens under the sheets.
Any other way to do it, actually?
Well, that's the question. Like, it might obviously depend on the version upgrade, on the difference of the version. So the question is, like, should we try and articulate any sort of thing we would like to preserve across a reboot like that? Would you
Yeah,
want to
exactly.
take some group secret from before and fold it into the new thing? Well, like, how much can we specify in advance? I don't know.
Well, let me try a simpler problem. Let us say we have a perfectly good group, and then some really fast new encryption, like AED algorithm comes out, and we'd like to upgrade to that. That doesn't require changing the group at all. So like, can we do that? Do we have to do that yet? I think that, because I think like even that is like some sort of like two generals problem of like figuring out that everybody like speaks, everybody speaks, cha-cha 30. Like I would suggest someone try to work that problem first. And then like, if you were able to work that problem successfully, then we can like work the problem of like upgrading the group.
Well, I mean, the underlying problem is that if you want to change something, whether it's a crypto primitive or something else, you need to make sure that everybody will understand what you're doing, right?
Exactly right.
Yeah. So I think this slide is kind of focused on the crypto ideas around the state management. I think there's also even more basic protocol understanding ideas.
That's why I was
which we've
asking
had, yeah.
Simpler problem, right?
Well, no, it's not. So the cha-cha 30 problem is still a crypto problem, because it's like, how do you, get everyone to do something different? But like, even being able to parse the welcome message that comes back when it chooses version 23.
Okay. I mean, so like, great.
Like, this is a question of
Okay. So fine. If you want to do it that way, okay. Like I decided I just added emojis. And I'd like everyone to be able to like send emojis, but I don't want to send emojis. But emojis look bad, like when I send to people who don't know emojis. So I need to know everybody in the group supports emojis. So like, do we know how to solve that? I mean, I think we may, because the thing is ordered. But I'm just saying, that's like a much easier problem. So like, maybe someone could write that down, and then we could all agree on like how you upgrade from like from like ASCII text to like MIME or something like that. And then once that works, then like we talk about how to do this.
Catriel, can we not solve that problem? To be clear, I'm going to lock my laptop.
You just don't like emojis, is that it?
To be clear, in many deployment contexts, you will unilaterally control all endpoints, correct? And therefore, you can just decide all my endpoints support emoji now.
I mean, maybe, but I mean, so if your deployment context is like web clients, that's true. But your deployment context apps, that's not true, because you don't know when people have updated or not. So yeah, so like even then it's like not trivial, but in open systems it's like much less trivial.
Right, but I would hope that MLS doesn't have to solve the problem of companies shipping different versions of apps to different phones.
No, they just haven't updated yet.
Right, I agree that is a problem. I'm not sure that's a problem that MLS should have to solve.
Well, I guess, but maybe not. But I guess my point is, like, if you can't describe how you solve that problem in this context, you can't describe how you solve the version updated problem in this context. So maybe you're going to write down, my apps are all under center control, and I make sure they're all the same. But but write that down then. Because like, if you're not willing to tell me how to solve that problem, then you can't tell me how to solve this one.
This is DKG. So Catriel, like, yes, there certainly are deployments where it seems possible. I'm sorry, my back is to you just because of where the microphone is. I don't mean to. Yeah, I could just talk to you in my back. There are situations where you can do that solution, but if what we're saying is MLS will only work for long-lived groups in scenarios where you can unilaterally have a flag day, then that needs to be written into the architectural draft. And it's currently not. Because, I mean, I hear you that like you don't want to deal with the open world problem because it's really hard. And is what we struggle with here at the IETF, right? If you're trying to standardize this here at the IETF, then either we need to say, by the way, you need to be sure that you have a way to upgrade all your clients synchronously, or we need to say that we have some idea about how we're going to do an upgrade path. Or we can say, your conversation is good only for as long as your deployed clients are synchronized. And then you'll have to find everyone will switch from wire to 3MA in order to upgrade.
I'll go away and think about it, but I'm not sure I'm convinced that solving you upgrade the version of MLS is the same as solving you want to negotiate some of your clients supporting emoji. But I'll go away and think about it.
So I'm going to go back to my previous comment, which, well, no, not quite that far. No, I think I was asking an even more simple question than that. Like I was going back to the not upgrading a group, but starting a group at all. Right, in TLS, I think in Quick, I'm looking at Thompson, because I think Quick has thought about this in some detail, this question of version, what stays constant among versions? Okay, I'm staying on mic, thank you. Right, so so there's this question of like what stays constant across versions. Like in TLS, we've like tried to keep compat in the client hello, right? So that the server knows what versions the client supports and can do proper version negotiation that way. So one could imagine writing some similar invariants here. And you know, what are the considerations we want to take into account here? Thompson, would you like to like provide some background from the TLS Quick point of view?
Yeah, so Martin Thompson, the thinking in Quick has been largely that you need to have some way of knowing, of signaling what version you intend to have, and that needs to be invariant across all versions. That's kind of the baseline, and then you need some way of sort of signaling that version is not okay somehow. And so TLS has far more in its baseline invariance, because it says that the client hello is this shape and shall henceforth forever be this shape. And so everyone who understands any version of TLS can say, well, the TLS client hello is always this shape, and therefore I can rely on that fact. Here, that's sort of a second order protocol consideration, though, I think. What I think you need to concentrate on is what are the states that you're looking at? What information exists in state one and information exists in state two, and what needs to be carried across from one to the other, and what needs to be changed in the two different ones. And you could imagine a world where you start a new group because you wanted to change the color of the pixels that were rendered, right? And maybe you run two groups in parallel at that point and have some constraints on how group membership is synchronized or what have you. And I don't really know. But there's a number of ways you can imagine this working, and none of them really sort of read on that particular aspect of the problem, unfortunately. Hopefully that wasn't too indecipherable.
Yeah, I think one of the things that you might try to think about to start out this discussion is cipher suites, because that's one thing in which a group is going to be different from other groups.
Right. Yeah. Cipher suites is one thing. New messages, new message formats might be another. So to summarize, what we have now in draft 04 is this, and this seems to be rather uncontroversial in the sense that nobody has jumped up to the mic to criticize that. So yeah, going forward, it's now a question how we channel that discussion.
Do you mind sliding back one slide? Leaving it up for a minute?
Yeah.
Okay, I spoke too soon. Yeah.
Yeah. How do you imagine this working? So you have a disparate community of clients, and they have potentially non-overlapping sets of supported versions.
Right.
Is the way this works, the first person to enter the room determines the version? Is it some sort of negotiation process? At what point does the final version, which I imagine is this thing on the right-hand side, at what point is that committed to? Because you can imagine a scenario where one person joins and that determines the version, and then basically whatever version the server or that person decides.
Right. So what happens is that there's one group initiator, always by design, that is going to retrieve a number of user init keys of the members that should be part of the group.
Right.
And from that, the initiator can determine what's possible at all. I assume the initiator would go for the highest possible version because it's the best one, but that remains to be seen.
Well, they get to choose, don't they?
But they get to choose, and then they commit to that in the welcome info. So everybody they invite, they tell them exactly which protocol version, and this is not an array, this is just one version.
Right.
At that point is to be used. So as of that point, you have a static group in the version, and that's it.
The cat's dead, basically, or alive.
So there's no negotiation as such between people. It is really just members advertising their capabilities in the user init keys, and then an initiator choosing from that.
Yeah, there's no negotiation in TLS either, but yeah.
This is DKG. So in this scenario, the consequences are, just to state them clearly, when you go to add someone to this group and you discover that they do not support the version that the group is in, you get some sort of message that this person cannot participate in this discussion. Right?
So, yeah.
And in the future, when you poll the members of the group and find that they are all capable of a new version, there's no way to upgrade the existing conversation. Or there's no explicit mechanism
not with
designed
this thing, yeah, exactly.
in this. This is just saying any particular conversation happens at one version that's negotiated at the initial assembly of the group. And if you want to change it later, we punt that for further down the road.
Yeah.
You punt that potentially by starting a whole new group. Someone said behind me and I couldn't see them.
Yeah, Jonathan Lennox pointed out that you can start a whole new group. The question there is whether there's anything that this group needs to do to ensure that starting a whole new group remains secure and retains all the properties that we're interested in retaining across that transition.
That was one of the open questions. Yeah.
So the
last one.
Whether or not you solve migrate the current group to a new version or not, you're still dealing with essentially the same problem, which is it secure going from state 1 to state 2?
Right.
Relaying from Jabba, perhaps not the right question for now. Omnia asks, what about the blanking problem / double join?
That seems completely unrelated in that sense.
That's what I thought.
I'm happy to discuss it later, but maybe we conclude this first. So, yeah, I mean, to me, it seems that this rather primitive mechanism could be a building block for something more mature, where you can one day upgrade a group. It doesn't seem to prevent upgradability of groups to me. So, I mean, I would say that we discuss the rest on the mailing list, preferably with concrete proposals of either how a group could be torn down and then resurrected on the application layer, or how we can smoothly upgrade a group with maybe a new kind of handshake message or whatever makes sense. I think that's it. So
that's all that we had scheduled for today, actually. It's a little early, but that's okay. We got a another hour and a half on Thursday. Unless there's something else that we want to add.
Well, I could like revert my agenda bash and put that topic back on this session's agenda.
The key schedule stuff.
The key schedule stuff, yeah.
Yeah, I mean, if we want to go over it, maybe we don't come to it again and we can rehack it or something.
No, we can do a quick.
Because we have 30 minutes.
It's Imad's that I was waiting for, but one of his team is here, so
All right.
he is representative.
Put him on the spot.
And Joel had also commented on that. So I think we've got quorum for that.
All right. You can have the clicker back. Wonderful. All right.
So tree warning. There's mostly been free of trees today, but I think there's a couple in this. Can you give me a line here? So just to recap, this is a problem we've talked about a couple times. Right now, to confirm that all the members agree on the state of the group, we have this group state object that gets fed into the key schedule and then used to confirm that agreement. Right now, that group state object includes the roster, the list of members in the group and their signature keys, and the tree, which has all of the DH public keys involved in this. Now, each of those, the size of each of those is linear in the size of the group. So the group state object is really quite large when you have a large group. And the upshot of that is that whenever you do a derived secret operation, which is the core operation in the key schedule, you need to now hash this linear sized thing, which is a lot of computation to do. So that has made some people have frowny faces. On the list, we had some discussion about this. I outlined a couple of objectives you could envision here. One is kind of trying to simplify things in general. You could try and have a smaller coefficient on this linear size amount of data. You could combine, pre-hash some things, make them smaller. But I think where it's probably more useful to go here is to try and reduce the amount of hashing you need to do for the derived secret operation. And get it down to a more log-like thing, so it's more parallel to the amounts of operation that we're used to in things like updates and removes. I'm proposing that we not take this stronger form of sublinearity here, trying to enable folks to get along with a sublinear amount of state. I think we're still going to. The proposal here is that each member will still be required to keep around the whole tree and the whole roster. But they won't have to hash all of it every time they update the key schedule. They'll have to hash some summary of it that will have log size. Does anyone feel real strongly that we should be aiming to allow endpoints to get away with a log size state? I see Joel shaking his head. Okay, so no one's leaping to the mic to say that. I agree, it's a desirable thing, but it requires a lot of extra information. The handshake message, I got a summary in a minute.
I think it's actually not desirable to have the clients keep a sublinear amount of state. Like, I think the clients in a secure messaging application should know who's involved in the messaging. Sorry, that was DKG.
Yep, fair enough. Okay, great. So I've got a PR up right now which sketches out a solution here. It follows the Ampelman hash approach that I'd outlined on the mailing list. In the PR, it's called a tree hash, which is somewhat less colorful, but also less likely to run into trademark issues. And well, the approach here is kind of Merkle tree-like, but with an extra input in the intermediate node, so you can align it to the tree structure. Right, so with the leaf nodes, we've collapsed the roster into this struct. So the leaf node info here holds both the leaf public key as well as the credential for the member holding that leaf. So you gather all that input together and put it in to the leaf hash in this overall hash structure. It's optional, obviously, because leaves can be blank if they're not occupied by a member. So that's how leaves get hashed, and then when you have an intermediate node, you have its left and right children, represented by their hashes, and you then feed in the public key at that node in hash form as well. There's an error in the PR because that should be optional, because you can also have blank intermediate nodes. You'll just have to figure out how to do that easily in the TLS syntax. But basically, you do this encode and hash dance up the tree, and you end up with a root hash, which is a summary of the whole tree. It's a commitment to the whole tree, just as in a Merkle tree. So you're committed to all of the public keys in the tree, as well as the credentials of the leaves, kind of by the transitive property of hashing. And the upshot, what that lets you do in protocol terms is that instead of having the group state contain the roster and the tree, and have this big linear size thing, you can just have the tree hash, which is a single hash value. And so you have a constant size group state object that gets fed into the key schedule, and it's all much faster. You do have to keep this thing up to date as you change the group. But the upshot of that is because we've aligned the hashing to the tree structure, you just have to do you have to do the same number of hashes as the nodes you change in the tree. So typically log, worst case linear. So that's the proposal. I wanted to briefly revisit, nobody was calling for trying to get to log state, but if you were inclined to go that way, here's why you might not. And the reason for that is, like, if you're going to try and let people get by with only log state, then you have to provide them the parts of the tree that they're not seeing. So you have to provide the hashes of the alternate children. And so you end up multiplying the size of your handshake messages by 2 or 3 times, which seems like kind of a lot of bloat in order to get smaller state. Per the last line here, like, there was some discussion of extension a little while ago. Maybe this is something, if people were really keen on this, that could be added as an extension point in the handshake messages. So you could say, here's your public keys, you need to update the tree, and as an extension, here's the hash values, you need to update the tree hash. Could be there, but it doesn't sound like there's a whole lot of energy and interest in the room. So overall, like, does this answer the mail? Does this sound like a sane proposal? Thumbs up from Joel. Questions, comments? Should we just merge the PR?
This is Karthik Bhargavan from India. So there is value in having the hash of the tree in many situations, but also value in having some representative of the transcript of all the operations that have happened so far. And they are kind of related, but somewhat different ways of looking at it. So do we already have a notion of the transcript, and where is that getting fed and where is getting hashed?
Yeah, that's perhaps a good discussion to have right now in parallel with this. I think the current PR, well, so in 04, as in the previous versions, there is a transcript hash there in addition to the giant stuff. And I think in the PR, it just takes the gigantic stuff and collapses that down to a tree hash. So you end up with a transcript hash and a tree hash.
And the transcript hash just chains over the tree hashes now?
No, the transcript hash chains over the actual messages that were sent. So it's a hash chain over the handshake messages that were sent.
Right. So just kind of abstractly, if it were the case, and it probably is, that if you know the initial tree and you know the transcript, if you agree on the initial tree and you agree on the transcript, then deterministically you should be agreeing also on the current tree. Right. So this does seem to be somewhat redundant, perhaps in a good way, perhaps not necessarily, where we have these two representatives of essentially the same state, where the transcript hash actually has strictly more information that you're agreeing on.
Well,
on how you got here.
More information in principle, but I think actually less information in practice, because if I'm a late joiner and you just hand me this transcript hash, yes, I have no way to interpret it.
Right. For late joiners, yeah, that is a problem. I agree.
Right. And so I think the question, I think Benjamin and I discussed some, is whether you could get away with only the tree hash and not using the transcript hash at all. Because the transcript hash doesn't add anything unless you've been there the whole time.
Does late, Jonathan Hoyland, does late joiner mean anyone apart from the first member?
Well, you get information from the transcript hash in proportion to the number of handshake messages you've seen, right? So you can verify a chunk of handshake messages, but the hash itself only authenticates messages that you have. So if you don't have, if you come into a group and you don't have the history, it doesn't give you anything.
So the first and second member then can fully interpret or fully understand this transcript hash?
Well, if I join at epoch 5 or epoch 200, say, and I'm given the transcript hash at that point, at epoch 501, like I can look at the transcript hash and the one I was handed when I joined and the sequence of messages I received in the meantime and verify that is good. But I can't verify anything prior to when I joined.
Sure. Okay. Thank you.
Yeah.
This is Joel Owen again. So does the transcript hash includes actual messages as well, not just group update stuff?
It only includes the handshake messages.
Oh,
so
only
messages
handshake,
change
good.
the state of the group. It doesn't include application messages, the actual messages we're protecting here.
All right, yeah.
Yeah, so it's not quite, wasn't the advertised topic of this section, but I think it's a question that one could ask is like whether we should delete the transcript hash from the protocol because might not be adding any value that we're not already getting from the tree hash.
Well, Karthik Bhagavan, Indriya. So from the transcript hash, the thing is that there could be multiple transcripts that lead to the same state. It is potentially possible. And considering that one path might lead through a malicious node who has done something, and another path might lead through perhaps only non-malicious nodes, in the analysis, it actually becomes important how we got here, not just where we got. Because of what could have been influenced and stuff. So for the analysis, when you do the security analysis, you certainly, I think, would prefer to have more information, which is what is there in the transcript hash. So one way of dealing with this is to say that the transcript hash should contain, the way you update the transcript hash is you take the current tree hash and then you add the new operation, whatever the new message was, and then you get the new transcript hash. And we could define a transcript as something that a transcript hash as something that sort of builds on top of the tree hash. Now that might be overkill, underkill, whatever. We can think about that.
Yeah, I think that's maybe one step too far, one step too fancy. I don't think there's a whole lot of benefit to having one hash instead of two in this case. A transcript hash, which is just the transcript messages, and the tree hash, which is just the tree. And those two get combined in the key schedule. But yeah, I'm happy to keep the transcript hash around if you think it has some value. It's not expensive really to the protocol. So, okay, sounds like folks are okay with this tree hashing scheme. So I guess we can probably just go ahead and land this. I'll take another pass through the PR and make sure we address like the optionality of blank intermediate nodes. I think we're good to go.
All right, thanks. Get to go eat cookies early. See you all on Thursday. So we need to check with make sure you got that list for Sophie's. This is right there. I'm going to do it now.
Develop an immunity to jet lag. No, it doesn't work that way anyway.
How's it going?
You?
I ran it by